settle in and let your breathing slow, because tonight you are standing beside a quiet crater lake in Cameroon. The air is cool, the water is still, and the dark surface looks perfectly innocent, like a sheet of glass laid over a deep old secret. You might think danger has to be loud, fire, shaking ground, a sky full of drama. But some places stay calm while they do something powerful and almost invisible. So, with a sleepless geographer keeping you company, you will drift through gentle coastlines, patient rivers, tired deserts, and slow-moving ice, learning how the earth changes everything without ever raising its voice. The lake in front of you is called Lake Nyos, and the strange thing is, it does not look like a threat. It looks like any other dark, round pool tucked into a green highland. It sits in a crater, which is already a clue, because craters are not created by calm decisions. They are what happens when the ground once had a very strong opinion. You are standing on volcanic land. Even if nothing is glowing, the hills around you hold trees and small farms, and the air smells faintly wet, like soil cooling after a warm day. Insects keep a steady rhythm. Somewhere in the distance, a night bird tries out a lonely call and then stops, as if it remembers there is no audience. And down at the center of everything, the water stays quiet, because this is the kind of danger that does not splash. This is a lake that can hold its breath for years. Lake Nyos is a crater lake, which means it sits in a bowl made by volcanic violence from long ago. Not the kind of volcano that gives you a cinematic cone and a red river of lava. This is subtler. The landscape here is part of a volcanic field, a region where Earth has opened small vents over time, like pinholes in a thick blanket. Deep below your feet, the planet is still warm. It never really cooled down. It just learned to keep its heat under control. Most of the time, in places like this, gases seep upward from the deep rock. Some of those gases are harmless, or at least ordinary. Water vapor, a bit of sulfur smell here and there, the faint mineral breath of the crust. But one gas matters tonight: CO2. Carbon dioxide is not dramatic. It does not have a color. It does not have a smell. You do not feel it on your skin. It does not announce itself with a warning siren. It is just there. And the annoying thing about it is, your body cannot easily tell the difference between air that will keep you alive and air that will quietly refuse. In most places, CO2 is mixed into the atmosphere and carried away by wind. It becomes part of the background. Trees inhale it. Oceans swallow it. Weather stirs it around like a spoon in a cup. But Lake Nyos is built like a trap. The crater walls create a sheltered basin. The lake is deep, and the water can become layered, with heavier water down below and lighter water above. That layering matters because water can hold gas the way a sealed bottle holds a hiss of carbonation. You know that feeling when you open a fizzy drink. The sudden rush, the bubbles racing upward, the little explosion of pressure that had been waiting patiently. That is the same idea, just stretched into geology and given a darker sense of humor. Down in the depths of Lake Nyos, water can dissolve CO2 under pressure. The deeper you go, the more pressure there is, and the easier it is for the water to keep that gas dissolved. It is like the lake is quietly storing a supply it never asked for. And as long as the lake stays calm and layered, the deep water stays deep, the gas stays dissolved, the surface stays ordinary. The trouble begins when something disturbs that layering. It does not have to be a grand catastrophe. It could be a landslide. It could be a cold rainstorm that cools the surface and makes it sink. It could be wind that churns the upper water harder than usual. It could be a small volcanic tremor, the kind that barely rattles a cup. If deep, gas-rich water is brought up toward the surface, the pressure drops. The water cannot hold as much CO2 anymore, so the gas comes out of solution, suddenly, violently, in a rising swarm of bubbles. And once bubbles start rising, they lift more deep water with them, like an elevator you did not ask to ride. That brings up even more gas-rich water. That releases even more gas. It becomes a chain reaction, a self-feeding release, a lake turning inside out. A limnic eruption is the term for it, which sounds neat and clinical, like a minor inconvenience on a laboratory form. In human terms, it is a lake exhaling a suffocating cloud. In 1986, Lake Nyos did exactly that. The release was silent, at least at first. No bright plume, no rolling lava, no movie soundtrack, just a sudden massive burp of CO2 pouring out of the water and spilling over the crater rim. And because CO2 is heavier than ordinary air, it did not rise and drift away. It sank. It flowed. It behaved like a cold fog, sliding downhill into valleys and low places, following the shape of the land with perfect obedience. Congratulations! The landscape has become a container. You can picture it now because the geography makes it easy. The lake sits high, and the villages sit lower, tucked into the folds of hills. At night, air can be still. The world can be quiet. People sleep with windows open because the day was warm and the evening finally softened. The gas cloud moved through the darkness like water. It filled hollows. It pooled in low ground. It hugged the earth, and in the worst places, it became thick enough to push away the oxygen people needed. The result was devastating. Many people and animals died, not from trauma, not from fire, not from panic, but from not having the right air in their lungs. It is a strange thing to imagine because it does not match your instincts. You think danger must be visible. You think you would notice. But CO2 does not make a show of itself. It does not smell like smoke. It does not roar like a storm. It is one of the few hazards that can move across a landscape and still feel peaceful. When scientists came to understand what happened, they found signs in the lake itself. The water had changed. Some reports described the lake surface looking disturbed, and the water taking on a different color afterward. The details vary because memory is soft around tragedy, and night is not a reliable witness. But the science became clearer with time. This lake was holding dissolved gas. Something triggered a sudden release. The basin and the valleys guided the gas where it could do the most harm. The planet did not need drama. It only needed geometry. Now, even that story has a second layer, because once you know the mechanism, you also notice the attempt at a solution. Lake Nyos has been fitted with degassing pipes. The idea is almost gentle. You insert a pipe down into the deep water, and you let the gas-rich water rise in a controlled way. As it rises, pressure drops. Gas comes out, and the flow can sustain itself like a fountain. It is a way of letting the lake exhale slowly, on schedule, instead of holding its breath until it panics. It is, in a way, a compromise with geology, because you cannot argue with a crater lake. You cannot negotiate with dissolved gas. You can only manage the conditions and hope. And standing here at the shore, you can feel how easy it would be to underestimate this place. The water is dark and steady. The surrounding slopes are quiet. The air is cool enough to feel clean. If you did not know the history, you might think this is a gentle landscape, one you could trust. You might even call it pretty, which is how the earth gets you. It presents the soft surface and hides the machinery underneath. And the machinery is always there, deep under your feet, turning heat into pressure, pressure into gas, gas into slow accumulation. The planet does not do it quickly. It does not do it loudly. It does it the way it does everything, with patience. The invisible hazard is what makes Lake Nyos feel so unsettling, even when you are safe. Not because you should be afraid tonight, here in this story, in this calm, but because it teaches you a lesson the earth likes to repeat. The biggest forces do not always look like forces. Sometimes they look like nothing at all. CO2 is a good example because it is familiar and also misunderstood. You hear about it as a climate gas, something that gathers high in the sky in tiny amounts. But here, in a still valley, it behaves differently. Here, it is not a distant concept. It is a physical thing, with weight, with motion, with behavior you can predict if you respect it. Carbon dioxide is heavier than the main gases in air, nitrogen and oxygen. So when it is released in large amounts and there is no wind to mix it upward, it tends to slump and settle. You could imagine it like a blanket, but not the cozy kind. More like one of those heavy, awkward moving blankets that refuses to fold properly. It droops into the lowest corner of the room. It gathers where the floor dips. It does not float. It occupies. This is why certain landscapes are more vulnerable. Valleys, basins, places where air can become still. Places where cool night air already slides downhill, bringing anything heavy with it. Places that feel sheltered because they are sheltered. The same shape that protects you from wind can also keep danger from leaving. It is not only Lake Nyos either. Other crater lakes can hold gas. Other volcanic regions can exhale. There is another lake not far away, Lake Monoon, which also had a deadly gas release in the 1980s. Different scale, same idea. The Earth repeating itself. Because why would it stop? And beyond lakes, volcanic gases can collect in other ways too. In some volcanic craters, carbon dioxide can gather near the ground and create pockets where animals collapse. There are places where guides warn you not to sit down in certain low areas because your nose is closer to the invisible layer. It is unfair, in a very Earth-like way. The hazard waits at the height of sleep, at the height of rest, at the height of lying down. And because this is a sleep-friendly walk through geology, you do not have to hold fear in your chest. You only have to hold understanding. Understanding is quieter. It sits in your mind like a small lantern. So you stay here for a while, at the edge of the lake, and you let your thoughts trace the layers. At the surface, the water is cool, slightly rippled by a faint breeze that comes and goes without commitment. If you could dip your fingers into it, you would feel the temperature change quickly, because crater lakes can be fed by rain and springs, and the deep water stays deep and cold. Below that surface, there is darkness and pressure and dissolved gas and a slow exchange between rock and water. Minerals leach out. Tiny particles drift. The lake is not inert. It is a living chemical space, even without fish, even without visible motion. And deeper still, beneath the lake bed, there is volcanic rock, fractured and restless in its own slow way. There are pathways for fluids. There are pockets where gas collects. There is heat that never turns off. The whole system is connected, not by drama, but by time. If you think about it long enough, the lake becomes less like a body of water and more like a lid, a calm, dark lid over a conversation happening underground. That is why the story of Lake Nyos feels like a geography lesson and a ghost story at the same time. The danger is not a creature. It is not a curse. It is a physical process quiet enough to be mistaken for nothing. And humans, being humans, often build their lives in places that feel safe because they have no obvious reason not to. The soil is fertile in volcanic regions. Rain falls, grass grows, trees hold onto the slopes. You can raise animals. You can build a home. You can sleep through the night. Then the earth reminds you that it has other plans, and it does not send a calendar invite. You can hold that thought gently, without squeezing it too hard. The lesson is not that the world is out to get you. The lesson is that the world does not organize itself around human senses. It does not care what you can see. And once you accept that, you start to notice other invisible forces, not just gases, but slow patterns of air, the way cold settles, the way heat rises, the way landscapes guide movement without ever touching you. Even now, in this story, you can sense the air around the lake cooling as the night deepens. Cool air is denser, so it slides downhill, like water, like carbon dioxide, like any heavy thing obeying gravity. That is one reason valleys get colder at night. The cold collects there. It pools. So the same geography that can guide a gas cloud also guides temperature. It guides fog. It guides frost. It guides where plants can survive. The planet is full of invisible rivers, and if you listen closely, you can almost hear them, not as sound, but as a pattern, a gentle, repeating logic. The crater walls around you are not perfectly round. They are worn, softened by rain, patched with vegetation. That is another quiet force at work. Water, not as a violent flood, but as constant, small movement. Droplets running down leaves, thin streams threading the soil. Seepage that finds cracks in rock and makes them wider, one grain at a time. You might be tempted to think of erosion as slow and harmless. It is slow, yes. Harmless, no. It is demolition with good manners. But for now, you stay with the invisible because the night is made for it. You can imagine CO2 as a traveler that prefers the low roads, released from deep within Earth. It rises through rock, dissolves in water, waits in the dark, then escapes and slides back downhill again. A loop, a cycle, a quiet commute. And there is something almost comforting about the idea that even a disaster has a shape. It has rules. It has physics. It is not random, even if it is rare. Scientists studying Lake Nyos measured the gas content of the deep water over time. They looked at how much CO2 was stored, how it changed, and whether the degassing systems were lowering the risk. They treated the lake like a patient with a chronic condition, something you manage, not cure, because you do not remove a crater, you do not cool the mantle, you do not close the vents of a planet. You adjust, you monitor, you learn the local habits of the earth, the way you learn the habits of a large animal you share space with. And this is where the story becomes a wider geography story, because Lake Nyos is not only about one tragic night. It is about the way landscapes store energy, store water, store gas, store history. It is about the way calm surfaces can be misleading. You can see that idea everywhere once you know to look. A snowfield looks smooth until you learn about crevasses hidden under thin bridges. A desert looks empty until you learn how flash floods carve it. A beach looks permanent until you learn it is borrowed sand, temporarily arranged. The earth is always rearranging itself. It just does not always do it on a human schedule. And as you stand here, beside the still lake, you can let your mind drift outward from this one basin to the larger region that holds it. Cameroon sits along a line of volcanic activity, sometimes called the Cameroon Volcanic Line. It stretches from islands in the Atlantic through mountains and volcanic centers on land. It is a reminder that the crust here has weaknesses, places where melt and gas can rise. The land is green because the climate brings rain, and because volcanic soils can be rich. The slopes grow crops, and the valleys hold villages. People live close to the land because the land feeds them. Geography is not a background. It is the entire arrangement of life. That is why invisible hazards matter. Not because they are everywhere, but because they can exist right next to ordinary routines. You can picture the morning after the event, when daylight returned and people stepped outside into a scene that did not make sense. No fire, no rubble, no obvious storm damage, and yet silence where there should have been animals, stillness where there should have been voices. It is one of the most unsettling kinds of aftermath, the kind that leaves no clear culprit, only absence. Over time, the explanation became clearer, and with explanation came a kind of grounded sadness, not a supernatural terror, just a sober recognition that the earth can do lethal things quietly. And tonight, you do not have to linger in that sorrow. You can acknowledge it, and then let it pass like fog thinning at dawn. Because the point of this journey is not to scare you awake, it is to show you the planet as it is, vast, patient, and sometimes indifferent in ways that feel personal, even when they are not. So you keep your attention on the physical story. You imagine the lake as a layered stack, warmed surface water on some days, cooler deep water below, and the deep water holding dissolved gas like a secret it never asked to keep. You imagine the pressure down there, the steady weight of water above, pressing the gas into solution. You imagine what happens if that deep water rises, the pressure drops, bubbles form, the bubbles rise faster. The rising water drags more rising water. The lake becomes its own pump. And then the gas spills over the rim, heavier than air, sliding downhill, filling valleys, obeying gravity with perfect loyalty. Geography is not only the setting, geography is the mechanism. In a different landscape, the same gas release might have mixed into wind and thinned quickly. In a flatter landscape, it might have spread differently. In a landscape with strong nighttime breezes, it might not have pooled as deeply. But here, the crater and the valleys made a shape that could hold an invisible flood. It is strange how often disasters are really about containers. Basins that hold water until they overflow. Slopes that hold snow until it collapses. Faults that hold strain until they slip. Forests that hold dry fuel until lightning arrives. The earth stores and stores and stores and then releases. Sometimes slowly, sometimes suddenly. And once you accept that the most serious forces can be invisible, it becomes easier to notice the slow forces too. The ones that do not burst out in one night, but work steadily, grain by grain. Because while Lake Nyos is famous for a sudden release, the land around it is being shaped by a different kind of quiet power. Rainfall, streams, seepage, erosion. The same water that fills this crater lake is also wearing down the crater rim. It is softening sharp edges. It is carrying tiny fragments downhill. It is slowly changing the shape of the basin, the same way time changes the shape of your thoughts, rounding off the sharpest corners. So you let your attention drift away from the invisible gas for a moment and toward the invisible work of water. Not the dramatic kind yet, not the flooding kind, just the ordinary movement of water across land. In the dark, you can almost hear it, even if you cannot see it. A faint trickle somewhere in the reeds, a small stream slipping through stones, the quiet drip of condensation falling from leaves. Water always finding a way to travel, always looking for the lowest place, always learning the shape of the ground by touching it repeatedly. And as that thought settles in, you begin to follow the idea downstream, toward places where water has had more time to practice. Toward the patient, slow violence of rivers, carving stone like it has nowhere else to be. The first thing you notice is the sound, not loud, not heroic, just a steady, textured hush, like fabric rubbing together in the dark. You are standing at the rim of a canyon at dawn, and the river at the bottom is speaking in a language made of pebbles. You might think you are looking at a finished landscape, solid, settled, permanent. Wrong. This is a construction site that never closes, and the crew is water showing up every day with the same small tools. Up here, the air is cool enough to feel clean in your nose. The rock under your boots holds the night chill and gives it back slowly. The sky is pale at the edges, and the canyon walls keep their shadows like heavy curtains that do not want to open yet. Down below, the river looks calm from this distance. A ribbon, a line, almost decorative. But that is the trick rivers always play. They look polite when you are far away, and they feel strong when you are standing in them. You start moving down a narrow path, the kind that has been worn by feet, hooves, and time. Each switchback drops you into warmer air. The scent changes as you descend, from dry stone to damp soil to something green and alive near the water. By the time you reach the river, the sound is no longer a hush. It is a constant, busy murmur, like the world talking to itself. The water slides around rocks, folds into little standing waves, and slaps softly at the bank, as if testing the edge for weakness. And the edge is always weak. Eventually, a river is gravity wearing a liquid mask. It begins somewhere high, where rain and snow collect, and it spends its entire life trying to be lower. That is its one goal: to fall, to find sea level, to stop moving. It just takes a long time, and it rearranges continents while it tries. You can watch the proof in the water itself. If you look closely, the river is not clear like a swimming pool. It carries a faint cloudiness, a muted color. That is not mood lighting. That is rock, ground down into tiny pieces, lifted and carried like luggage. Congratulations, you are watching the landscape get disassembled. The process is simple and cruelly patient. Water pries at cracks. It wets them, dries them, freezes in them, sometimes expands and pushes the walls apart. Tiny fragments break loose. The river catches those fragments, rolls them, knocks them into each other, and rounds their edges until they look harmless. That rounding is not kindness. That rounding is evidence of violence that has been repeated enough times to become smooth. If you pick up a stone from the riverbed, it sits heavy in your palm. It is cold from the current. It might be speckled, banded, or plain. But whatever it is, it used to be part of something bigger. A cliff, a hillside, a mountain shoulder. Now it is a traveler, halfway through its long trip to becoming sand. And sand, in the end, is just rock that has been humbled. The river does not only carry stones along the bottom, it also carries finer material in the flow and even dissolves some minerals completely. A little bit of the land becomes invisible chemistry in the water. So even a river that looks gentle is still doing work you cannot see. Erosion is the headline everyone knows, but rivers also deposit, and that is where the story gets sneaky. When the water slows down, it loses the strength to carry big pieces. It drops them. First, the heavy gravel, then the sand, then the silt. Over time, that makes bars, islands, deltas, floodplains. The river is both a thief and a builder, stealing from the uplands and gifting to the lowlands. You can see it in the curve ahead, where the river bends. On the outside of the bend, the current runs faster. It bites the bank, undercuts it, and pulls it down in chunks. On the inside of the bend, the water is slower, almost lazy. It drops sand in a pale crescent, as if making a little beach for itself. This is how a river moves sideways across a valley, over centuries, chewing one bank, feeding the other, migrating like a slow animal that never sleeps. Humans love to call rivers peaceful. That is because humans like poetry more than maintenance. If you build too close, the river will eventually introduce itself properly. It will take your fence first, then your garden, then the corner of your house, and it will do it with a sound like ordinary water. So you have to watch your own life collapse in a very calm soundtrack. You can hear that calm soundtrack now. The water keeps moving. The birds start to wake up. A few insects hover near the surface, stitching invisible lines above the current. It all looks like morning. But the river has two personalities. One is what you are seeing. The other is what it becomes when the sky decides to open. Floods are rare enough to feel like exceptions, and common enough to be part of the contract. In dry seasons, a river can shrink to a thread. In wet seasons, it can spread out and take the whole valley back, like a landlord collecting rent. You can imagine the flood without watching it. The water rises, brown with soil. It lifts branches and logs. It nudges boulders that looked immovable yesterday. It climbs over the bank and moves through grass as if the grass is not there. It finds old channels, old scars, and uses them again. And when it is done, it leaves behind a new layer of silt, a thin, fertile dusting that makes floodplains so tempting to farm. This is the joke, of course. The same floods that ruin your house are the reason the land is so good for crops. River valleys are generous, and then they remember they are rivers. All of this slow work adds up into big shapes, the kind you can see from above. Canyons, gorges, ravines. Those are not cracks that happened all at once. They are the result of a river insisting for a very long time that the land should be somewhere else. You can picture the river as a saw, but not a fast one. A saw that cuts one grain at a time. A saw that never gets tired. A saw powered by gravity and rain. And the thing about time is that it does not care if your mind can hold it. Give the river enough years, and it will cut through almost anything. Give it enough centuries, and it will carve a valley that changes the weather inside it. Give it enough millennia, and it will make a canyon so deep that clouds form below the rim and storms happen under your feet. When you stand above a canyon like that, you are not looking at a place. You are looking at a measurement of time. The river keeps going even when the land changes. If the land rises, the river cuts down. If the land sinks, the river slows and deposits. If the climate dries, the river becomes seasonal and sharp, and flash floods do the cutting in bursts. If the climate wets, the river becomes steady and the valley broadens. Rivers respond. Always. They are not in charge, but they are persistent, and the land is not as still as you want it to be. Sometimes the ground itself is rising very slowly, pushed up by tectonics. The river does not complain. It just keeps cutting to keep its path to the sea. That tension between uplift and erosion is how some of the world's dramatic landscapes are maintained. The ground rises, the river slices. The ground rises again, the river slices again. It is a slow argument that never gets resolved, only reshaped. If you want to understand why a canyon exists, you do not only look at the river, you look at the whole region. The rock type, the climate, the uplift, the vegetation, the history of storms, because a river is a summary of everything that happens in its basin. Every slope, every soil, every drop of rain, all of it eventually gets introduced to the river. You are standing in that summary now. The river is cold when you kneel near it. The current tugs at your fingers if you dip them in, and you can feel the constant motion, the way it never holds still, never pauses to admire its own scenery. If you follow the river long enough, it will carry you out of the canyon into a wider valley. The walls relax, the path straightens, the river begins to wander. It develops loops, bends, and oxbows, little curls of water that get cut off and left behind as still ponds. Those abandoned loops become quiet places. Frogs, reeds, mosquitoes doing what mosquitoes do. with no sense of shame. The river leaves behind these small, sleepy leftovers as it continues onward. Even the river's mistakes become habitat, and as the river approaches flatter land, it slows. It drops more sediment. It builds up its own bed, sometimes so much that it ends up perched above the surrounding plain. That is when it becomes dangerously confident. A levee breaks and the river spills out, carving new channels across the lowland like someone dragging a wet brush across a page. Humans see that and think, we should control this. So humans build levees. They straighten channels. They dredge. They pour concrete. They tell the river where to go, like giving instructions to a sleepwalking giant. Sometimes it works, for a while, but rivers do not forget how to move. They remember their floodplains. They remember their old courses. They remember the easiest path downhill. And when a big storm arrives or snow melt comes hard and fast, the river tests every wall you built patiently until it finds the one spot you cheaped out on. Congratulations! You have invented maintenance. There is a strange comfort in that, if you let it be what it is. The river is not malicious. It is not angry. It is simply consistent. It will always take the route that physics allows. It will always move what it can move. It will always work with the tools it has. And those tools are small. Water molecules, grains of sand, bits of dissolved mineral, moving over and over again. That is the sleepier truth of erosion. It is not an event. It is a habit. You start walking along the bank, following the curve of the channel. The ground is softer here. There are footprints in the mud, animal tracks that cross and vanish. The river carries tiny sticks and leaves in the current, and they spin in small eddies, caught in little whirlpools that are born and die in seconds. Eddies are miniature lessons. They show you that even in calm flow, energy is being spent. The water is always negotiating with itself. Friction, turbulence, drag. And every negotiation costs the river a little bit of its strength, which it pays by dropping sediment. If you look at the riverbank, you can see layers. Dark soil on top, lighter sand beneath, maybe a band of pebbles. Each layer is a past flood, a past season, a past chapter. The river writes its history in thin sheets, stacked quietly like blankets. Somewhere upstream, rain is falling. Somewhere downstream, the water is already calmer, already wider, already closer to the sea. The river connects those places without asking permission. And the sea is where the river is always going, whether you are paying attention or not. When you finally let your mind follow the river's long path, you start noticing how the pieces it carries are not just going downhill. They are going toward an ending that is not really an ending. Because the river does not destroy rock, it just changes the rock's address. A boulder becomes cobbles. Cobbles become pebbles. Pebbles become sand. Sand becomes silt. Silt becomes mud. Mud becomes a delta. A delta becomes a coastline. A coastline becomes a shelf. A shelf becomes seabed. And seabed, given enough time, becomes rock again. So the river is part of a cycle that feels almost polite until you remember it is built on constant loss. The mountains lose themselves to make the plains. The plains lose themselves to make the seafloor. The seafloor eventually will be pushed back up somewhere else by forces that do not care how long you live. But that is a thought for later. For now, you stay with the river's quiet industry because it is easier to hold. A river is a moving thing you can see. You can listen to it. You can understand it without needing a microscope or a volcano. And after watching it for a while, you notice something else. The river is not only cutting the land, it is also delivering the land to the edge of the continent. Every grain it carries is headed toward a meeting with waves, so you keep following the idea downstream, not quickly, not in a rush, just letting the river lead you like a slow guide. The canyon opens into a broader valley. The air grows heavier with moisture. The vegetation changes. The river becomes wider, less noisy, more reflective. At some point, the water begins to taste different in the air. Salt, faint but unmistakable. A coolness that feels like open space. And then you hear it, not the river anymore, but something larger repeating itself. A low, steady pulse. Waves arriving on schedule, as if the planet has been tapping its fingers for billions of years and never gotten bored. By the time you reach the coast, the light is gone again. Night has returned, because this is not one day. This is a drift through places. The shoreline is a black curve under a darker sky, and the sea keeps breathing in and out with a tired patience. You stand on sand that is cool underfoot. It gives slightly, then settles. Each grain is a tiny piece of somewhere else, a mountain, a cliff, an old riverbed, now here, gathered into a temporary carpet by water that will eventually take it back. The ocean smells like minerals and distance. It smells like old storms. The wind is gentle tonight, but persistent. It moves your hair. It presses damp air against your skin. It reminds you that coasts are never sealed off from the wider world. And you might think a coastline is a line, a border, a clean edge between land and sea. Wrong. A coastline is an argument, and the waves are very committed. Every wave that slides up the beach is a small act of work. It lifts grains, it shifts them, it sorts them by size. When the water retreats, it drags some grains back and leaves others behind. The beach is constantly being edited, rewritten in tiny revisions you only notice if you come back again and again. This is why the same beach can look different after a storm. The slope changes. The sandbar offshore moves. A patch of pebbles appears where smooth sand used to be. It is like waking up and finding your furniture rearranged, except the decorator is the Atlantic, and it has no taste. The tide adds another layer of motion, pulling the shoreline in and out like a slow breath. On a high tide, the waves reach farther. They touch the base of dunes, the foot of cliffs, the edge of human decisions. On low tide, the sea backs away and exposes a wide, wet plain of sand that glistens under moonlight. But no matter the tide, the waves keep arriving. They come from winds far out at sea, from storms you never saw, from weather systems that died days ago. The energy travels across the ocean in long swells, and it spends itself on the coast. So the shore is not local. The shore is where distant weather finally pays its bill. If you walk along the beach, you can feel how the sand changes under your feet. Fine grains in one place, coarser grains in another. A strip of shells, a line of seaweed left by the last tide, marking where the ocean reached like a signature. That seaweed line is also a warning. It shows you that the sea comes higher than you think. It always does. People love to build just above the last high tide line because it feels safe and the view is nice, and humans have never once been punished for optimism. Then a storm arrives with a surge and the sea decides to redecorate. Coastal erosion is not a neat process. It can be slow, with cliffs crumbling a little each year, or it can be sudden, with a whole section collapsing overnight. The ocean works at the base of cliffs like a thief at a foundation, removing support grain by grain until gravity handles the rest. If the rock is soft, the sea carves quickly. If the rock is hard, the sea waits longer. Either way, the sea does not get tired. It has had practice. You can stand near a cliff at night and hear small sounds, trickles, drips, the occasional sharp crack. Those are not ghosts. Those are bits of rock giving up. Salt water seeps into fractures. Waves slam air into cracks and compress it like pumping a bicycle tire inside the cliff face. The pressure widens the crack. Bits fall. The cliff retreats. And every fallen chunk becomes ammunition. The sea uses those rocks to grind the base even more, tumbling them in the surf like rough tools in a polishing machine. The result is a coastline that is always moving, even if the map pretends otherwise. Beaches are even more mobile. They are not fixed features. They are piles of sediment, borrowed and lent by currents. Longshore drift is the quiet conveyor belt that moves sand along a coast. Waves usually approach at an angle, not straight on. They push sand up the beach diagonally, then gravity pulls it back down more directly. Over time, that zigzag motion walks sand down the shore, grain by grain, like a crowd slowly shuffling out of a stadium. If you build a jetty or a breakwater, you interrupt that shuffling. Sand piles up on one side and the other side starves. One beach grows fat and wide, the next beach down becomes narrow and fragile. Humans often respond by dumping more sand there, a process called beach nourishment. It is exactly what it sounds like, shipping in sand like you are refilling a leaking bag. Congratulations, you are feeding the ocean, and it is still hungry. At night, with the waves repeating, it is easy to forget how much land has been lost this way. Entire villages in some places have had to retreat inland. Roads have been abandoned. Buildings have collapsed into the surf with a sound that is oddly small for the amount of money involved. And then, after the storm, the sea looks calm again, as if nothing happened. That is the coastal version of what Lake Nyos taught you. The biggest changes do not always announce themselves in a way your senses respect. Sometimes the planet is polite while it takes things away. Coasts also change because sea level changes. Over the last ice ages, sea level has risen and fallen by amounts that redraw continents. When ice sheets grow, they lock up water and lower sea level. When they melt, sea level rises and floods lowlands. So there have been times when today's beaches were grassy plains, and times when today's coastal cities would have been underwater without a single wave needing to be dramatic about it. The shore is a moving compromise between land elevation, sediment supply, storm energy, and sea level. Change any of those, and the shoreline shifts, and the sea, as always, keeps breathing. You stand close enough to the surf that mist touches your face. The water is cold. It numbs your ankles if you step in. Foam forms, collapses, forms again. Under the surface, sand is being lifted and dropped in constant rearrangement. And here, at the edge, you can feel how the river's journey ends and begins again. The grains carried down from the canyon have arrived. They are no longer in fresh water. They are now in salt water, subject to tides and currents and waves. Some grains will stay here for a while, becoming part of the beach you are standing on. Some will be pulled offshore and stored in sandbars. Some will be swept along the coast by longshore drift, traveling sideways for miles without ever leaving the ocean's reach. And some will become airborne, because the shore is not only a meeting of land and sea, it is also a launch pad. When the beach dries, when the wind picks up, the finest grains can be lifted. Not the heavy sand, not the shells, but the dust, the tiny mineral fragments. They rise in little puffs, barely visible in moonlight, and drift inland. Salt spray goes too, carried on the wind, settling on plants and windows and skin. It is why coastal air tastes the way it does. It is why metal rusts faster near the sea. The ocean is always reaching into the land with invisible fingers. And speaking of invisible travelers, wind is not just a breeze. Wind is transport. Wind is erosion. Wind is a patient broom. So when you finally step away from the waterline, leaving the tired sea behind, you follow the wind inland toward places where it has nothing to do but sweep and sweep, toward deserts that look empty and are actually full of history. The desert welcomes you the way a quiet room does, by offering no help at all. The heat of the day has drained away, and now the air cools fast because there is nothing here to hold warmth. No thick canopy, no damp soil, no ocean nearby to moderate anything. The sky is huge. Stars show up with embarrassing clarity, as if the atmosphere has been scrubbed clean. The horizon is flat in some directions, jagged in others, where mesas and ridges stand like old teeth. The sand underfoot is soft in places and crusted in others. It holds the faint memory of warmth from hours ago, but it is already turning cold. In the distance, a dune line curves like a slow wave, frozen mid-roll. You might think deserts are just places where nothing happens. Wrong. Deserts are places where everything happens slowly enough that you can hear your own thoughts. And the first thing to understand is that deserts are not always ancient emptiness. Many deserts used to be something else. There have been times when parts of the Sahara were greener, with lakes, rivers, and grasslands. Not fantasy, not myth, just climate doing what climate does. Shifting rainfall belts over thousands of years. Monsoons move. Ocean temperatures change. Earth's orbit wobbles slightly, tilting and precessing in cycles that change how sunlight is distributed. Those slow celestial adjustments can turn a wet region dry, and later turn it wet again, if the timing is right. So when you stand in a desert, you are often standing in a former landscape, a retired ecosystem. Dry lake beds can become salt flats. River channels can become faint scars, only visible from above. Fossil shorelines can remain as ridges, marking where water once touched. Even the sand itself can be recycled history. Some dunes are built from the remains of ancient rocks, ground down by time. Some are built from the sediments of old rivers. Some are built from the dust of vanished lakes. The desert is not a blank. It is an archive with the pages scattered. Wind is the librarian here, and it is not gentle, even when it feels like a soft breeze on your face. Wind cannot pick up big stones easily. It mostly moves the fine stuff, dust, silt, sand. But that is enough. Sand grains bouncing along the ground, a process called saltation, act like tiny chisels. They strike rocks, chip them, sandblast them smooth. Over long periods, wind can sculpt stone into strange shapes, undercut pillars, streamlined ridges, rocks polished into curves. If you have ever seen a car after a dusty road trip, coated in fine powder that clings to everything, imagine that powder moving at speed for centuries, and you start to understand desert erosion. Wind also sorts. It takes finer particles and carries them farther. That is why desert sand is often so uniform. The grains similar in size. The wind has been picky, and it has had time to be picky. The very finest dust can travel across oceans. Dust from North Africa fertilizes parts of the Amazon rainforest, delivering minerals like a strange long-distance gift. The desert, in that sense, is not isolated. It participates in global systems, even while looking empty. And then there is the sound. On some dunes, under specific conditions of grain size and dryness, sand can make noise, a low hum, a boom, a singing tone when it slides. It is not supernatural. It is grains rubbing in unison, a kind of accidental instrument. Congratulations, you have found a landscape that plays itself. Life in the desert adapts by becoming quiet and efficient. Plants grow deep roots or wide, shallow roots, depending on where water hides. Some store water in thick tissues. Some shrink their leaves to reduce evaporation. Some live fast, appearing after rain, flowering, seeding, and vanishing again before the ground dries. Animals do similar things. They burrow. They become nocturnal. They conserve moisture. They can survive on water made internally from food metabolism. Because the desert does not hand out free drinks. And people, when they live here, learn roots, wells, seasons, and the value of shade. Desert cultures often become experts in reading subtle signs, wind direction, cloud shapes, the taste of the air before a rare rain. But deserts still demand respect. The heat can be lethal, and the cold can surprise you at night. Distances deceive. The horizon looks closer than it is. The ground can be hard crust over soft sand that traps a vehicle. Water sources can be seasonal, and maps can be optimistic. The desert does not hate you. It just does not notice you. There is another trick deserts play. They preserve. In humid places, organic material rots quickly. In deserts, dryness slows decay. Footprints can last longer. Ruins can stand for centuries. Ancient campsites can leave traces like the night before. Even bodies, if you want the darker version, can mummify naturally. So deserts become museums of human time, held inside geological time. Caravan routes, rock art, abandoned towns, shipwrecks on dry land where the shoreline used to be. Shipwrecks on dry land are one of those facts that feels like a dream until you remember sea levels and shifting coasts. The desert can contain things that do not belong in it because the desert used to be something else. And when the wind runs out of loose sand to move, It does not stop. It simply looks for another surface. It scours bedrock. It strips soil. It leaves behind gravel armor called desert pavement, where fine dust has been removed and heavier stones remain like a protective layer. That gravel armor can make the desert look stable, but stability here is an illusion made of leftover pieces. Underneath, the fine particles are gone, carried away to become someone else's soil, someone else's haze, someone else's sunset. And this is the quiet theme that keeps returning. Movement without drama, transport without spectacle. The earth changing the world by taking small things and moving them patiently. Eventually the land rises, or the air cools, or latitude shifts. The desert gives way to something colder. Moisture, instead of vanishing, gets stored. Not as a lake, not as a river, as ice. So you keep traveling, following the wind's last carried grains northward and upward, until the air becomes sharp and the ground begins to hold winter like a grudge. The cold place greets you with sound first, a deep, subtle crack like wood settling in a cabin. Then another. Then a long, low creak that seems to come from the ground itself. You are standing beside a glacier. In daylight, it would be blinding. At night, it glows faintly, reflecting starlight in a muted way. The surface is not smooth. It is ridged, dirty in places, streaked with gray where rock dust has been mixed in. The ice has a color that feels impossible at first, a dense blue, like the glacier is holding the sky inside it. You might think ice is still. Frozen means stopped. Right. Wrong. A glacier is a river that learned patience. It moves just slowly enough to insult your sense of urgency. The weight of all that ice causes it to deform internally, crystals shifting and sliding. At the base, meltwater can lubricate the contact with rock, letting the glacier creep forward. Not fast, but always. If you put a marker in the ice and came back later, you would find it has traveled. The glacier will have carried it downhill, like a conveyor belt made of frozen time. This is why glaciers shape land so effectively. They are heavy and they move. They press down into valleys and scrape. They pluck rocks from bedrock, ripping blocks loose as meltwater freezes in cracks and acts like glue. They grind everything underneath into fine powder called rock flour, which can make glacial rivers look milky and pale. You can see that milkiness in streams coming out from under the ice. The water is cold enough to hurt your teeth if you drink it. It rushes away from the glacier with a frantic energy, as if relieved to be liquid again. The glacier's surface creaks and pops because it is under stress. It flows over uneven ground, and the top layer fractures into crevasses, deep cracks that can be hidden under thin snow bridges. They look harmless until you are standing on one, which is not recommended if you enjoy having a future. Congratulations, you have found a landscape that hides holes in plain sight. Glaciers also leave behind very particular shapes. If a river carves a valley, it tends to make a narrow V shape, cutting downward. If a glacier fills that valley, it scrapes the sides as well, widening and smoothing it into a U shape. So when you see a broad, rounded valley with steep walls and a flat floor, you are often looking at a place where ice used to be the main tenant. Glaciers leave moraines too, piles of debris pushed along and dumped when the ice melts back. Those ridges can dam water and form lakes. They can also look like natural embankments, which humans sometimes build on, because humans love building on things that were deposited by unstable ice. The glacier's influence does not end when it melts. It rewrites drainage patterns. It changes where rivers flow. It leaves behind basins that fill with water. It creates fjords when sea level rises and floods glacial valleys, turning them into long, steep, walled inlets. So when you stand beside a glacier, you are looking at a land-shaping machine, quiet, relentless, heavy, and you can feel its weight even if you cannot measure it. The air near the ice is colder. It spills downhill like a slow breath. If you walk close, you feel a chill radiating from the surface, as if the glacier is sucking heat out of the world. In some places, you can hear water running inside the ice, hidden channels called molins, swallowing meltwater and delivering it to the base. The glacier is not a simple block. It is a system, cracked and layered, with internal plumbing, and lately, in many parts of the world, glaciers have been changing, retreating, thinning, pulling back uphill like an animal withdrawing from a space it once dominated. It can feel strange to watch something that looks eternal behave like something temporary. The glacier seems ancient, and it is, but it is also sensitive to temperature and snowfall. Small changes in climate over decades can shift the balance between accumulation and melting. So glaciers can shrink quickly, at least by geological standards. They can leave behind raw ground, fresh rock, unstable slopes. They can create new lakes dammed by loose moraine, lakes that sometimes burst out in sudden floods, again, stored energy, and sudden release. The planet loves that theme, but even in retreat, glaciers keep doing their quiet work. They keep creaking, they keep sliding, they keep grinding stone into powder. They keep feeding rivers with cold meltwater in spring and summer, supporting ecosystems and human water supplies downstream. And when a glacier finally pulls away from a valley, it leaves behind a shape that tells you what it did. Smoothed bedrock with scratches, carved by stones trapped in the ice. Rounded hills called roches moutonnées, where the glacier polished one side and plucked the other. The land wears the glacier's fingerprints. As you stand here, listening to the ice settle and shift, you begin to sense something deeper. Because ice is not the deepest force. It is a surface expression of temperature, of climate, of the atmosphere's habits. And beneath all of it, beneath the ice, beneath the rock it scrapes, beneath the crust itself, is heat. Earth is not cold inside. It is not finished. It is a warm engine with a thin skin, and everything you have seen tonight is shaped by that internal restlessness. So when you step back from the glacier's blue shadow, you start to notice places where the cold gives way to warmth that should not be there. A patch of ground that steams in winter, a smell of sulfur on the wind, a line of dark rock that looks fresh, as if it has not had time to soften. And the path leads you gently towards slopes built from old ash and old lava, volcanic landscapes that look peaceful, mostly because they are between appointments. The ground under you becomes darker, rougher, made of broken stone that crunches softly with each step. There are plants here, but they are scattered, hardy, opportunistic. They grow in cracks where a little soil has collected, as if nature is slowly testing whether this surface is safe to invest in. The air carries a faint mineral scent, not always sulfur, sometimes just hot rock that has cooled but remembers. In some spots, you can feel warmth rising through your soles, a gentle heat like a low radiator under the floor. You might think a volcano is only a volcano when it erupts. Wrong. A volcano is a volcano when it exists at all. It is a vent, a weakness in the crust, a place where the inside gets to communicate with the outside in ways that are sometimes polite and sometimes not. The polite version is what you see in geothermal areas. Steam rising from vents like breath in cold air. Hot springs tinted with minerals, painting the ground in soft colors. Oranges from iron, whites from silica, greens from heat-loving microbes. The dramatic version is lava, ash, pyroclastic flows, the kind of fast violence you do not sleep through. But most of the time, volcanoes sit quietly, looking like normal mountains. That is why people live on them. The soil is fertile because volcanic ash breaks down into mineral-rich ground. The slopes catch rain. The elevation can create cooler climates in the tropics. Volcanoes make good farms until they do not. There is also a strange honesty to volcanic land. The rocks can look new, sharp-edged, not yet rounded by long erosion. You can see layers of past eruptions in cliffs and road cuts. Darker flows, lighter ash bands, deposits of pumice. Each layer is a date in the volcano's journal. And volcanoes are not random. They cluster along boundaries and hotspots, along subduction zones, where one tectonic plate dives under another and melts rock into magma, along rifts, where plates pull apart and magma rises to fill the gap, over mantle plumes, where heat rises from deeper within Earth like a slow torch. So when you walk on volcanic slopes, you are walking on a signpost of plate tectonics. The crust is broken into large plates and they move very slowly, about as fast as your fingernails grow, which is an insulting speed for something that builds mountains. But the Earth does not care about your calendar. Those plates ride on softer, hotter rock beneath. They push, pull, and slide past each other. Where they collide, land crumples and rises into mountain ranges. Where they separate, new crust is born at mid-ocean ridges. Where they slide, stress builds and releases as earthquakes. And volcanoes often mark those zones of interaction, like stitches on a wound. You can stand on a quiet volcanic flank and imagine the deeper plumbing. Magma chambers, not necessarily huge pools, often networks of melt pockets and conduits. Gas dissolved in magma under pressure, waiting. Because magma holds gases the way deep lake water holds CO2. Under pressure, quietly, when pressure drops, gas comes out. Bubbles form. Bubbles expand. Expansion drives eruption. It is the same basic idea you met at Lake Nyos, just hotter. Earth repeats its patterns across different materials. Gas dissolved in water. Gas, pressure holding it in, a trigger releasing it. A sudden change that looks like drama, but is really physics doing its job. Even the word dormant is misleading. Volcanoes do not sleep like humans sleep. They pause, they recharge, they build pressure slowly. They wait. The good news is, this mountain has not erupted in hundreds of years. The bad news is, that just means it has had time to reload. And humans, once again, build nearby because the slopes are fertile and the views are nice. Cities sit in the shadow of volcanoes. Airports are built on old lava plains. Roads cross ash deposits as if they are just dirt. And then, when an eruption finally happens, everyone acts surprised, as if the mountain did not spend centuries being shaped like a warning. Still, volcanic landscapes can feel strangely calming at night. The rocks hold heat, the stars are sharp, the air can be dry and clean, and the knowledge that there is warmth below makes the surface feel like a thin blanket over a bigger reality, which it is. Because when you step back far enough, the volcano is just one small place where the deeper engine leaks through. The real story is the motion of whole regions, continents drifting, ocean floors spreading, mountain belts forming and eroding, over timescales that make human history look like a brief weather event. So you widen your view. You stop thinking like a hiker. You start thinking like a plate. You are standing still, but you are also traveling. The ground under you is moving in a direction you cannot feel. It is sliding over the mantle like a slow conveyor belt, carrying forests, cities, lakes, and you. It does not feel like motion because everything around you is moving with you. That is the trick. You are in a moving reference frame, trapped inside the same raft as the rest of the landscape. If you could watch from space over millions of years, you would see continents drift apart and collide like slow shopping carts in a parking lot. The collisions are not loud most of the time. They are pressure building, rock deforming, crust thickening. Mountains rise where plates meet, not because Earth wants beauty, but because there is nowhere else for the rock to go. When India collided with Asia, the Himalayas began to rise. The uplift continues. The mountains are still growing in places, even as erosion tries to shave them down. It is another slow argument. Uplift versus erosion. Push versus scrape. And earthquakes are the brief messages from that slow pressure. A fault holds stress for years, decades, centuries. Then it slips in seconds and the ground shakes, and humans remember that the crust is not a solid floor. But most of the time, the motion is silent. It is so slow that you could live your whole life in one place and not notice that you have traveled miles on a tectonic plate. Yet the evidence is in the rocks, matching coastlines, fossil distributions, magnetic stripes on the ocean floor, mountain chains that line up across oceans when you reconstruct past supercontinents. The planet has been rearranging itself for billions of years, assembling and breaking apart supercontinents like a person who cannot stop reorganizing furniture. And all of that motion affects climate too. Where continents sit influences ocean currents. Mountain ranges influence rainfall patterns. The opening and closing of seaways changes how heat moves around the globe. So plate tectonics is not only about earthquakes and volcanoes, it is about why deserts exist where they do, why glaciers form where they do, why certain lakes sit in certain basins. It is the deep geometry under the surface. And after thinking at that scale, it becomes oddly comforting to return to something smaller again, to water, to stillness, to a dark surface reflecting the night. Because even still water, as you learned, has layers. So your thoughts begin to drift back toward that crater lake in Cameroon, back toward Lake Nyos, not to repeat the tragedy, but to see it differently now. After rivers and coasts and deserts and ice and fire and moving continents, to see the lake as part of the same restless planet, a quiet surface sitting above slow machinery, holding time in solution. And as that image returns, you can almost feel the air cool again, the insects returning to their steady rhythm, the crater walls rising like a bowl around a secret. You move through the highlands in your mind, along roads that curve between green slopes. You pass small farms and trees and dark patches of forest. The night is soft here. Clouds sometimes gather and then dissolve. The land feels alive and ordinary. Then the lake appears again, a dark circle set into the land, reflecting faint starlight. From a distance, it looks calm enough to trust, but now you know how many calm things are busy underneath. The lake is still a container, still layered, still connected to deep volcanic gas sources through fractures in rock. The difference is, now you also understand the other containers on Earth. Floodplains holding water until levees break, ice dams holding lakes until they burst, faults holding stress until they slip, volcanoes holding gas until it expands. Earth stores, and then Earth releases. So you stand by the shore again, and you let the quiet water be what it is. Not a villain, not a monster, just a system. Rain falls into the crater over months and years. Springs seep in from the sides. The surface cools at night and warms by day. The wind sometimes stirs the top layer. Below, the deeper water stays colder and denser, reluctant to mix. In that deep layer, dissolved CO2 can accumulate again, slowly. If the supply continues, that is why the degassing pipes matter. They are an attempt to keep the deep layer from becoming too loaded, a way of letting the lake exhale on purpose, in small, steady breaths, instead of one sudden, dangerous one. You can imagine the pipe quietly lifting deep water, bringing it upward. As pressure drops, bubbles form, and the rising bubbles help lift more water. A self-sustaining flow, like a controlled fountain, that never becomes a surprise. The surface might show a small disturbance, a rippled patch, a faint line of bubbles. Nothing dramatic, just the lake being managed. And there is something very human about that. We cannot change the deep geology, but we can sometimes add a little plumbing. We can watch. We can measure gas levels, temperature profiles, mixing patterns. We can learn the lake's habits and keep it from holding its breath too long. It is not victory. It is coexistence. The lake at night remains quiet. Mist can form over the surface when the air cools. The crater walls keep wind out, so the mist lingers. Insects hover at the edge. Frogs call from somewhere you cannot see. The water reflects the sky with a dark, glossy patience. And you can rest in the strange fact that the most powerful things here are not visible. Not the dissolved gas, not the deep pressure, not the slow seepage through rock, not the gradual reshaping of the crater rim by rain. Even time itself is invisible. You only see what it leaves behind. That is the gentle theme, tying everything together. Gas, water, wind, ice, heat, moving continents, all of it is motion that does not need your attention to continue. All of it is change that does not require drama. Earth does not rush because it does not have to. It is already old enough to wait you out, so you stay by the lake a while longer, watching the surface, for any hint of movement, a small ripple, a faint breeze passing and then leaving, a soft sound from the forest behind you, and you remember that even the calmest surface is only a surface. Underneath, layers stack up. Heat rises, gas dissolves, water collects, pressure builds and releases. Landscapes slowly adjust. The lake holds the night like a secret, and in that secret, your mind can keep drifting, following the planet's quiet processes wherever they lead next, without needing to arrive anywhere in a hurry. And if you keep staring at that dark surface long enough, you start noticing how a lake is never just a lake. It is a meeting point. Rain from the sky, minerals from rock, heat from the deep crust, a basin shaped by old violence, now pretending to be a calm bowl of water. You can feel the basin around you like a quiet hand. The crater walls make a sheltered room. Wind comes in softened, if it comes in at all. The air settles into layers at night, cool at the bottom, a little warmer above. The insects keep working, because insects always keep working. And you start thinking, not about the night the lake released its breath, but about the long, quiet days in between. The ordinary days, the days when nothing happens, which is most days, and is exactly how the earth prefers it. Because in between the rare events, there is the slow problem of stratification. That is the calm, technical word for layering. The lake becomes a stack of waters that do not mix easily. Warmth and cold, light and heavy, oxygen rich at the top, oxygen poor at the bottom. A division that can last for months or years, depending on wind and seasons. In many lakes, seasonal cooling and storms stir everything up. The surface water chills, becomes denser, sinks, and forces deep water upward. That turnover is like shaking a bottle, except the bottle is a crater and the soda is a living ecosystem. Nutrients get redistributed. Oxygen gets delivered downward. Fish get a fresh arrangement of chemistry. But some lakes do not like to turn over. Deep crater lakes in sheltered basins can stay stubbornly layered. Their bottom waters can become isolated, sitting in darkness long enough to become their own world. That isolation is comfortable for dissolved gases. It is comfortable for the slow accumulation of anything that would rather not be disturbed. So, Lake Nyos, in its quiet way, is an extreme example of something that happens elsewhere too. The idea that still water can hide a second, deeper lake beneath it. And once you understand that, you understand why the safety measures have to be persistent, not dramatic. Those degassing pipes are not a one-time fix. They are more like a routine. The lake cannot be allowed to become overconfident again. You can imagine the work crews who installed them, hauling equipment into a remote crater, setting up floating platforms, drilling and lowering long pipes into the dark. It is an odd image. Humans doing plumbing in the middle of a volcanic landscape, like trying to install a smoke detector inside a sleeping dragon. The pipes bring up deep water that is rich in CO2. As it rises, the pressure drops, bubbles form, and the flow helps lift itself. It is a controlled exhale, a managed release. In the daytime, you might even see a constant plume of bubbles at the surface, like the lake has decided to simmer. And what is happening, quietly, is that the deep water is being drained of its gas. Not all at once, just enough that the lake is less likely to reach that tipping point again. There is another concern here that you do not notice by looking at the water. The natural dam, Lake Nyos, is held in by a barrier of volcanic material. Not a neat concrete wall, just rock and deposits left by ancient eruptions. Some studies have pointed out that this dam can be weak, fractured, vulnerable to collapse, which means there is a second possible disaster separate from gas, a sudden outflow of water, a flood down the valleys. Congratulations, you found a lake with more than one way to ruin your week. And that is the thing about crater lakes. They are not just scenic, they are engineered by geology. And geology is not known for generous safety margins. A crater is a wound. A crater lake is water collecting in that wound. A volcanic dam is a bandage made of broken stone. So the place asks for monitoring, measuring gas levels, watching the stability of the rim, watching rainfall patterns, watching anything that might disturb the layers. It is a relationship with a landscape that requires attention. And the landscape will not remind you politely. Standing here, you can let that thought pass without panic. You are not here to feel dread. You are here to feel scale. You are here to feel how Earth can be calm and hazardous at the same time. The way a deep ocean can look smooth while hiding currents that could pull you under. And as you hold that scale, you can widen it just a little more. Because Lake Nyos is famous, but it is not alone in the category of quiet, invisible danger. The planet has other ways of removing oxygen from your plans. In volcanic regions, there are places called moffetts. They are vents that release carbon dioxide gently, like the ground is sighing. Sometimes the gas collects in small depressions. Sometimes it fills a hollow in the forest. You can walk into a low spot, and your body will react before your mind understands why. Dizzy, weak, confused. Then you leave the hollow and you feel normal again, as if nothing happened. In some places, you will see dead insects or small animals in those depressions. Not because the Earth is cruel on purpose, just because heavy gas settles where gravity tells it to settle, and living things happen to breathe there. There are also volcanic gases that are not as polite as CO2. Hydrogen sulfide, for example, smells like rotten eggs. It is a rare kindness, a dangerous gas that at least announces itself. But even that has a twist. At high concentrations, it can deaden your sense of smell. The warning turns off. The hazard stays on, and there are places where gases seep out under snow, creating pockets, places where the ground looks solid and safe in winter. And underneath it is a slow poison layer that does not care about your boots. So when you think of danger on Earth, you can think of it in categories: loud and visible, like a landslide; loud and invisible, like an earthquake at night; quiet and visible, like a cliff eroding under a house; quiet and invisible, like a gas cloud that flows like fog. Lake Nyos sits in that last category, which is why it feels like a bedtime story. With teeth, it is the kind of place that teaches you to respect what you cannot see. And that lesson, once learned, tends to stick. Because now, when you look at anything that appears still, you wonder what is happening inside it. Still water, still air, still ice, still ground. Even continents which feel like the definition of stillness, are moving. And you already felt that slow motion earlier, like standing on a conveyor belt you cannot sense. But you can bring that feeling back here, beside the lake, because this volcanic line exists for a reason. The crust here has a history of being stretched, fractured, and given pathways for deep gases. The surface is quiet, but the architecture is not random. You can picture the deep rock beneath Cameroon as layered and cracked, ancient basement rock, younger volcanic deposits, intrusions that cooled underground, faults and fractures that act like plumbing, Earth's internal heat rising along weaknesses, finding the easiest routes, seeping, dissolving, storing. Nothing in geology is ever perfectly sealed. It is all porous in the long run. Fluids find a way, gas finds a way, water finds a way, time finds a way. So the lake sits here, doing what basins do, collecting, holding, waiting. And if you stay with that thought, you start to feel the comfort in it. Not comfort like safety, comfort like honesty. The planet is not pretending to be stable. You are the one who wants it to be stable. The planet is simply being itself, running slow processes with no regard for your bedtime. You turn your attention again to the crater walls, softened with vegetation. Even here, erosion is at work, rounding the rim, carrying tiny particles into the water. Each rainstorm contributes. Each little stream cuts a small groove. Each leaf that falls becomes part of the soil, then part of the sediment. Over many years, the lake slowly fills with material. Sediment settles on the bottom in thin layers. If you could take a core sample, a long cylinder of mud pulled from the depths, you would see time stacked like pages. Dark bands, light bands, maybe ash layers from distant eruptions, maybe changes in pollen from shifts in vegetation. The lake records the landscape like a diary written in silt. That is another quiet irony. The same lake that can release invisible gas can also preserve invisible history. And since you have already followed grains of rock from canyon to coast, you can follow these finer grains too, settling through the water column, landing softly in darkness, building a floor that rises by fractions. The lake bed is not static. It is slowly accumulating, slow enough that you would never notice, fast enough that in the long view, it matters. The long view is where geology always wins. Because even this crater is temporary. Not tomorrow, not in your lifetime, but eventually the rim will erode. The basin may fill. The water may drain. The landscape will change its mind. And if the deep gas supply continues without a lake to trap it, it will seep out elsewhere. It will find a different expression, a different vent, a different hazard, or perhaps a harmless release into moving air. Everything rearranges. Nothing stays in its assigned role forever. Which brings you to a softer thought, one that does not feel like a warning. The idea that Earth processes are often cyclical, not because Earth is trying to be elegant, but because physics reuses patterns. Gas dissolves under pressure. Gas comes out when pressure drops. Water carries sediment. Water deposits sediment when it slows. Ice stores water. Ice releases water when it warms. Continents assemble. Continents break apart. Coasts advance. Coasts retreat. It is all variations on storage and release, movement and pause. And once you are tuned to that rhythm, you start hearing it everywhere, even in places that seem completely unrelated to volcanoes. For example, you can think about lakes in general and how they are often temporary features on the landscape. Many lakes are young in geological terms. Some form behind landslides, some in glacial basins, some in rift valleys, some in volcanic craters. But lakes tend to fill. Rivers bring in sediment. Wind brings dust. Plants grow, die, and add organic material. Over time, a lake can become a marsh, then a meadow, then a forest. A lake is often a phase, not a final form. So, Lake Nyos is a phase too. A dramatic phase. Yes, but still, a phase. A basin that currently holds water and dissolved gas, and someday will be altered by the same slow forces you followed tonight. If you want to feel very small in a very calm way, you can imagine a future where this crater is just a gentle hollow. No lake, no pipes, just a damp valley with thick grass and people walking through it with no memory of what happened here, because memory, like lakes, tends to fill. But you are still here now, in the present of this story, and the lake is still a dark mirror. So you let it be that, and you let your mind drift into the details again, the ones that feel more like science and less like metaphor. Carbon dioxide dissolves in water more easily under pressure and in cold conditions. That is why deep lake water can hold more. That is why stratification matters. When the deep water stays deep and cold, it becomes a storage zone. If mixing brings it upward, pressure drops and the gas escapes. So the key hazard is not the presence of gas alone. It is the combination of gas supply, depth, layering, and a trigger. The lake needs to be charged like a battery. It needs to be capped like a bottle. And then it needs a shake. And that is why monitoring involves measuring not just gas, but temperature and density profiles. Scientists can lower instruments into the water to see how the layers are arranged. They can measure dissolved gas concentrations at different depths. They can watch how those values change over time. You can picture a small boat on the lake in daylight, drifting over deep water, a line of cable lowering sensors into darkness. It is quiet work, patient work, the kind of work that respects the lake by not forcing it into drama. And there is something almost soothing about that image. Humans and nature meeting in careful measurement. It is not conquering. It is listening. But there is always that other layer, the human one. The communities around Lake Nyos were shaped by the land, fertile volcanic soil, water sources, grazing areas, paths through the hills. People did not choose the crater because they wanted danger. They chose the region because it offered life. And that is the tragedy and the truth. Humans often live in risky landscapes because risky landscapes are also productive landscapes. Floodplains are fertile. Volcanic slopes are rich. Coastal plains are flat and convenient. Mountain valleys have water. The same features that make a place habitable can also make it hazardous. So the question is rarely, why do people live here? The question is, how do people adapt once they realize where here actually is? In the years after the disaster, relocation and risk management became part of the story. Warning systems, education, continued work on degassing. The slow effort to build safety into a landscape that does not offer it naturally. It is not simple. It is never simple. Geography is not a problem you solve once. It is a condition you live with. And now, with that thought hanging gently in the air, you can return to the lake again, not as a single of a larger idea. Earth does not need spectacle to be powerful. The lake is quiet. The forest is quiet. The crater walls stand still. And yet, inside the water, chemistry continues. Inside the rock beneath, gas continues. Inside the crust, heat continues. Inside the planet, convection continues, churning mantle rock in slow currents that you will never see directly. And those mantle currents, over millions of years, move plates, create volcanic lines, open pathways, build basins, and set the stage for a lake that can exhale. So the lake is part of a chain, and the chain is long. If you trace it far enough back, you end up in deep time, where Africa itself has been shaped by rifts, uplifts, and ancient collisions. The continent carries scars that are old enough to feel mythical, and yet they are physical. Lines of weakness, basins, highlands, the slow shaping of a platform that seems stable until you look closely. Even the idea of a stable continent is relative. Africa has rift systems where the crust is being pulled apart. In East Africa, the land is cracking slowly, forming valleys and lakes, volcanoes and fault escarpments. Not because the planet is angry, but because plates move, and sometimes they move away from each other. A rift is like a seam splitting on an old piece of clothing. The fabric is the crust. The tension is heat and convection and gravity. The tear is slow, but it is persistent. In places where the crust thins, magma rises more easily. Volcanoes appear, lakes form in fault-bounded basins, deep water collects. Gas can be part of that story too, depending on local geology. So Lake Nyos is not an isolated oddity. It is a local expression of a bigger planetary habit. And that habit is what you have been following all night. The habit of slow change interrupted by brief releases. Now, you might notice that your mind wants to collect this into a neat moral, something like respect nature. But nature does not want your morals. Nature wants your physics. So you keep it simple. The lake is calm. The lake is deep. The lake can store gas. A trigger can release it. The landscape shape controls where the gas goes. Humans can reduce the risk with degassing and monitoring, but cannot remove the underlying geology. That is the whole story, told gently. And in the quiet after that, you can let your attention soften again. Back to sensory details, the cool air sliding down the crater walls, the slight dampness, the faint chorus of insects, the water reflecting the sky so darkly it looks like it might be a hole. You think about how many surfaces on Earth are like this, surfaces that look finished. A desert crust, a glacier's snow bridge, a coastal dune, a calm river pool, a quiet fault line, a crater lake at night. All of them are surfaces. All of them are masks over motion. And since you have time, you can follow one more thread that Lake Nyos offers. One that is not about danger, but about how scientists know what they know. Because it is one thing to say a lake released carbon dioxide, it is another thing to prove it, to convince people, to separate rumor from mechanism. After the event, investigators looked for volcanic eruption signs. They considered landslides. They examined the chemistry of the water. They measured gas concentrations. They compared it to Lake Nyos, where a similar but smaller release had occurred. They also studied how carbon dioxide behaves in basins, using models and field observations. They looked at the topography of the valleys, the likely flow paths. They observed that vegetation close to the ground could be affected, and that animals low to the ground were especially vulnerable. They gathered testimonies, imperfect but valuable, about sounds heard, smells not smelled, sensations felt. Science, after a disaster, is often like that. A reconstruction done with fragments. You do not get to rerun the event. You have to infer it. And the inference, in this case, fits the physics with uncomfortable elegance. A gas-charged lake, a sudden overturn, rapid degassing, a dense cloud spilling downhill. So the reason this place stays in textbooks and documentaries is not just because it was tragic. It is because it was a rare, clear example of an unusual process, one that can happen in other deep, gas-rich lakes. Lake Kivu, for example, much larger, sitting between Rwanda and the Democratic Republic of the Congo, holds enormous amounts of dissolved gases, both carbon dioxide and methane. That lake is stratified, deep, and influenced by volcanic activity. It also has millions of people living near it. Lake Kivu has been studied carefully. It has industry that extracts methane from deep water for energy, which is both clever and also, in a very human way, tempting fate with paperwork. The lake is monitored because a large limnic eruption there would be catastrophic. So Lake Nyos becomes part of a family of lakes that teach the same lesson. Deep water can store gas, quiet surfaces can hide charged systems, and geology does not announce itself. That knowledge changes how people approach these places. It adds instruments, caution, management. It adds a layer of human planning onto natural layers of water. And for tonight, that is enough. You do not need to chase the story into every other lake on Earth. You only need to feel the idea settle. The world is full of quiet mechanisms. Now, as you linger here, you can let your mind drift to the rim of the crater again, and then beyond it, into the surrounding highlands. The slopes are green and damp, and in the distance there are valleys where air pools at night, the same valleys that once guided a gas cloud. Those valleys also guide water. When it rains, streams gather. Small channels join. A creek becomes a stream becomes a river, and a river becomes the kind of patient force you followed earlier, carving and carrying. So even here, in volcanic country, the older sculptor is still water. Given enough time, water wins most arguments. It wears down lava flows. It cuts gullies into ash deposits. It undercuts volcanic dams. It smooths everything into something softer. And the irony is that this is how hazards can interact. A landslide into the lake can trigger mixing. Heavy rain can cool surface water and increase instability. Erosion can weaken natural dams. Everything is connected through simple processes that add up. It is always the small motions adding up. You can imagine a rainstorm in the highlands, warm rain on green slopes, runoff gathering, brown with soil, a sudden pulse entering the lake, the surface layer cooling, the density changing, the layering adjusting. Most of the time, nothing dramatic follows. The lake absorbs it. The layers remain stable enough. The pipes keep working. The night returns, and the insects keep their rhythm. But the lake is always a system in motion, even when that motion is hidden. And because you are thinking like the sleepless geographer, you let the dark humor sit beside the awe. The earth is old, indifferent, and occasionally a lake that can suffocate a valley without making a sound. A coastline that eats houses politely. A glacier that looks eternal until it vanishes. A desert that used to be a wetland. A continent that moves at the speed of fingernails while building mountains. None of this is personal. And that is, strangely, the comfort. Because if the planet is not acting out of malice, you can stop taking it personally. You can replace fear with understanding. You can watch the machinery without needing to fight it in your head. So you stay in this quiet place a while longer, letting the crater lake be a symbol of invisible processes. You let the water reflect the sky. You let the crater walls hold the night air. You let the thought of deep time move through you like a slow current. And then, very gently, without any need to hurry, your attention begins to drift outward again. Not away from the lake, but through it. Through the idea of layers. Because layers are not just in water, they are in rock. They are in ice. They are in the atmosphere. They are in the planet itself. The crust is layered with stories. Old volcanic deposits over older bedrock. Sediment layers laid down by vanished rivers. Ash layers from eruptions that no one remembers. Soil built up and washed away. Built up and washed away. Even the air above the lake has layers at night. A stable layer can trap fog. A stable layer can trap gas. A stable layer can trap smoke from a cooking fire, making it hang low in the village until morning winds stir it. Stability feels peaceful. But stability is also what allows accumulation. That is the broader truth. Stillness can be a kind of tension. Calm can be stored energy. And speaking of stored energy, you can feel it under your feet again. The warmth that never turns off. The planet's internal heat leaking through volcanic land. That heat is why gases exist. That heat is why plates move. That heat is why the Earth is not a finished sculpture, but an ongoing project. So you keep that warmth in mind, like a small ember, as you stand by the coolest looking surface. Cold water, night air, still reflections, heat below. Earth loves contrasts. Cold skin, hot core. And if you follow that idea long enough, you start wondering about other quiet places where heat and chemistry meet water. Other lakes, other vents, other basins. Not because you need a new destination yet, but because your mind likes to wander through a connected world. One mechanism leading to another. One quiet hazard reminding you of another quiet hazard. There are places where the ground breathes carbon dioxide so steadily that trees die not from drought, not from fire, but from suffocation at the roots. In volcanic regions, carbon dioxide can seep through soil and displace oxygen underground. Plants can look stressed in patches, yellowed and stunted, forming strange dead zones that map the invisible flow of gas. There are places where warm springs carry dissolved minerals to the surface, building terraces of white stone. Over centuries, travertine precipitated from water that loses carbon dioxide and drops its load of calcium carbonate. It is the same physics again. Pressure and chemistry changing. Gas escaping. Minerals precipitating. Slow construction. You could stand at such a spring and watch new rock being formed quietly, in real time. Not fast enough to excite you, fast enough to matter over generations. And that is a pleasing counterpoint to Lake Nyos. Not all carbon dioxide stories are lethal. Some are constructive. Some build landscapes. Some feed ecosystems. Some simply join the atmosphere and become part of global cycles. So the gas itself is not evil. It is context. It is containment. It is concentration. It is timing. The same way water is not evil. It is context. A river in its channel is life. A river out of its channel is a disaster with paperwork. An ocean at low tide is a walk. An ocean at storm surge is a demolition crew. Everything depends on where the energy goes and how much room it has. So you let your attention return one last time to the shape of the crater, the bowl, the sheltered room, the container, because that is the most practical geography lesson here. Topography matters. It is not just scenery, it is destiny, written in slope and depth and curvature. A valley can collect cold air. A basin can collect fog. A hollow can collect carbon dioxide. A floodplain can collect water. A coastal bay can collect storm surge. And sometimes, the most important feature of a landscape is not what it does on sunny days, but what it does when something unusual arrives. A rare storm, a rare landslide, a rare overturn, a rare slip along a fault. Earth is mostly routine, and then, occasionally, it is not. And you, tonight, are learning the routine, because routine is where understanding lives. So you stand there, listening to insects, watching mist drift over dark water, feeling the crater walls hold the air still. You think about the pipes continuing their quiet work. You think about the deep water being slowly drained of its burden. You think about all the other quiet systems on Earth being managed the same way. Levees and floodways, avalanche control, volcano monitoring, earthquake-resistant design, coastal retreat plans that no one wants to fund until after the waves arrive. Humanity, forever doing small adjustments to a planet that does not negotiate. And for now, in this moment of the story, it is enough to be an observer with a lantern of understanding, to know that the calm surface is real and the hidden depth is also real, and both can exist together without contradiction. The mist thickens slightly in patches, then thins. A faint breeze touches the lake and disappears. Somewhere on the far shore, something moves in the brush, then goes still again. The night keeps its steady pace, and your mind, still wandering, begins to settle into the idea of layers again. How every place you visited tonight had them. The river had layers in its banks, flood after flood. The coast had layers in its dunes and cliffs, storm after storm. The desert had layers in its buried lakes and fossil shorelines. The glacier had layers of snowfall compressed into ice. The volcano had layers of ash and lava. The continents had layers of crust, welded and broken and welded again. And this lake, quiet and dark, has layers that matter more than they should. You keep watching the surface, not expecting anything, just noticing. Because noticing is the whole practice. And as you keep noticing, you find yourself thinking about how a lake like this can look different, under different light. In daytime, the water might be a deep green or blue. The crater walls might look friendly, covered in plants. The danger would feel even less real. At night, it becomes easier to believe in hidden things because night removes detail. Night makes everything simpler and more mysterious. Night turns a lake into a mirror and a mirror into a question. So you let it stay a question for now without forcing an answer. The science is there. The facts are there. But the feeling can remain open, like a door left ajar in a quiet house. Because there is still more to say about this place and about places like it, about how Earth hides its strongest processes under the most ordinary